Imagine looking up at the night sky and seeing a star so bright it dominates its entire region of space. For millions of years, it shines with incredible power, lighting up nearby planets and casting its glow across vast distances. To any observer, it feels permanent, like it will burn forever. But inside that brilliant sphere of light, an invisible clock is ticking. Every star, no matter how large or bright, is living on borrowed time. A star is not just a ball of fire. It is a delicate balance of forces locked in a cosmic tug-of-war. On one side is gravity, the force trying to pull all the star's matter inward, crushing it under its own weight. On the other side is nuclear fusion, the process in the star's core where hydrogen atoms fuse into helium, releasing enormous amounts of energy. This energy pushes outward, perfectly countering gravity's inward pull. As long as these two forces remain in balance, the star lives. It shines steadily, sometimes for billions of years. But the balance is fragile, and eventually, the star begins to run out of fuel. Deep within the core, hydrogen slowly depletes. The star begins fusing heavier elements, helium into carbon, carbon into oxygen, and so on. Each stage burns faster than the last. What once lasted billions of years can shrink to mere millions or even thousands. The star is essentially racing toward its own end, and it cannot stop. When fusion can no longer produce enough energy to push outward, gravity starts to win. The core begins to collapse inward. In smaller stars, this collapse can stabilize into a dense object called a white dwarf. But in stars that are many times larger than our Sun, the collapse becomes catastrophic. In a matter of seconds, the core implodes. Temperatures skyrocket into the billions of degrees. Pressure rises to unimaginable levels. And then, in a blinding flash of energy, the outer layers of the star explode outward in one of the most powerful events in the universe, a supernova. For a brief moment, this single dying star can outshine an entire galaxy. Shockwaves ripple through space, and heavy elements forged in the star's core are scattered across the cosmos. The iron in our blood, the calcium in our bones, and the gold in our jewelry were all created in explosions like these. In death, stars seed the universe with the materials for future worlds and life itself. But what remains after the explosion is where the story becomes truly extraordinary. If the original star was large but not enormous, the collapsed core may form a neutron star, an incredibly dense sphere where protons and electrons are crushed together into neutrons. A teaspoon of neutron star material would weigh billions of tons. Yet even this extreme state is not the limit of gravity's power. If the star was massive enough, usually more than 20 times the mass of our Sun, even neutron pressure cannot stop the collapse. The core continues shrinking, smaller, denser, heavier. Gravity becomes so overwhelming that nothing can resist it, not even light itself. At this point, a black hole is born. Despite the name, a black hole is not an empty hole in space. It is an object, or more accurately, a region where matter is compressed into an incredibly tiny volume. Its gravity is so intense that it warps the very fabric of space and time around it. The boundary surrounding it is called the event horizon, the point of no return. Once anything crosses this boundary, escape is impossible. What once was a radiant star becomes invisible, detectable only by its effects on nearby matter. Gas and dust spiral toward it, heating up and glowing brightly before vanishing beyond the horizon. Entire stars can be torn apart if they wander too close. Yet despite their destructive reputation, black holes are not cosmic villains. They are a natural part of the universe's life cycle. In fact, without the massive stars that eventually form black holes, the universe would be a very different place. The elements necessary for planets, oceans, atmospheres, and living organisms would not exist. Black holes are born from destruction, but their origins are tied to creation. They are reminders that endings in the cosmos often lead to new beginnings. So when we gaze at the night sky, we are not just looking at distant lights. We are witnessing stories unfolding across millions of years, stories of birth, balance, collapse, and transformation. Some of those stars have already ended their lives. Some have already exploded. And somewhere, right now, a massive star is reaching the end of its fuel, quietly preparing for the moment when gravity will finally win. and a new black hole will emerge in the vast darkness of space.